Okay. Now, if we graph these things point for point, we would see that the equations for f of x equals the base b raised to the x power, in other words, y equals b to the x power, that's called our exponential function. They actually follow a pattern. When the base is greater than 1, it looks like the picture on the left. When the base is a fraction or a decimal between 0 and 1, it looks like the picture on the right. Now, the base always has to be positive. There's no place that we see a negative base. Base is always going to be positive. Okay, so the deal here is that we don't, we see that when the base value is greater than 1, you can imagine that the graph looks like an airplane that's coming in for a landing on the airstrip, which is the x-axis, and it's landing from the right to the left on the airstrip. But when the base is a fraction between 0 and 1, it's coming in for a landing from the right onto the airstrip. As you go to the left, it's landing on the x-axis. Well, one way or another, you're going to have to figure a way to remember what these guys look like. But these are the two categories. Now, I want you to notice a revelation I had here. Aha. When the b value is greater than 1, if you keep graphing this for different values of the base, as they get larger and larger, greater than 1, they get larger, they go towards infinity, the base value gets larger. Each of your graphs is going to be standing taller. It's still going to be making a landing on the left side onto the x-axis, but it's going to stand up more alert, stand up taller. While on the right side, the graph that has the base as a fraction or a decimal between 0 and 1, as the base value gets closer and closer to the smallest number, 0, the graph is going to be standing up taller in that case. Okay, so that's something you wanted to think about. That'll help you do sketches. Now, here's an example. Given f of x equals base a raised to the x power, and then I included a graph. I just didn't mention to you what the base is, a, but I did a graph here for you, and I put 2 points on that graph, the ordered pair 0, 1 and the ordered pair 2, 4. You're asked to find the equation of the function. So I gave you the bare bones equation, f of x equals a to the x. You need to figure out what the a is. Okay, so the first thing I notice is that clearly this airplane is coming in for a landing from the right side and landing on the left side onto our airstrip, the x-axis. And what does this mean? This means something about the base. Remember what I just said above? If it's coming in like this for a landing from the right and landing on the left side, that means the base is greater than 1. Okay, so we know our function, f of x, is going to be a to the x, where the base a is going to be greater than 1. We know that much. The a value will be greater than 1. So let's figure out what this base a is, and we'll have the answer to the question. Okay, we're given an ordered pair, xy equals 2, 4. So we know that when we evaluate f of 2, which is a to the 2 power, the second power, it's got to equal 4. Great, a to the second power equals 4. Let's find out what a is. Take plus or minus the square root of both sides. We get a equals plus or minus the square root of 4, which is plus or minus 2. But both of the choices in note 111 have non-negative bases. In other words, you cannot have a negative base. You throw away the negative answer for a because you cannot have a negative base for these functions. So a is just equal to the positive 2. And the conclusion, therefore, is that our function, f of x, is equal to base 2 raised to the x power. And we're finished.